So in this video, we'll look at the topic of optimization, and it is an application of differentiations. And the key point here is that we try to minimize or maximize certain quantities depending on the situation on the problem, right? And let's look at a concrete example. So please look at the current problem. You are given two numbers. They can be positive, they can be negative, it doesn't matter, but they have to satisfy the condition that the difference between the two numbers is 100. And I would like to look for the pair of numbers such that the product of them is minimum. And you may be a little bit confused what I'm asking here. Anyway, as long as you give me two numbers such that the difference is 100, and also among all these possibilities of the two numbers, the product is minimum, and that would be our final answer. We are searching for such pair of numbers such that the product is minimum, and you can randomly give it a try. For example, if you pick these two numbers, you see the difference of the two numbers obviously is 100, right? But if you take the product, it's gonna be 0 because 0 times 100 is 0. So for example, you can randomly try other pairs. For example, you can try 50 and 150. The difference between the two numbers is 100 obviously, and if you take the product now, it's gonna be 7500. And obviously the second choice of the two numbers is bigger than the first choice. We are trying to search for the minimum choice of the products among all pairs such that the two numbers have the difference of 100. For example, the numbers can be minus, why not? I mean, I can easily pick maybe this pair, like minus 99 and 1. One number is negative, the other number is positive, and the gap between them is 100. So if you multiply them, it's gonna be minus 99. And this number obviously is the minimum among these three pairs. I would like to search for the minimum product. I hope you get my point in this problem. And of course, you can try it out, you can try more possibilities, but the fact is that there are infinitely many such choices. So we try to attack this problem by calculus, and let's take a look at a pair of two numbers, and we want to fix it such that the difference between them is 100. So it means mathematically we have the first equation. Let's say x minus y is actually 100, right? The pair of the two numbers satisfy the first condition now. And what is the meaning of the second statement? Let's look at the product. Of course, now the product means I look at x times y, right? And I try to minimize. So try to minimize this quantity. And it's obviously a calculus problem, but one of the bad thing about this part is that we actually have two variables now. And we usually can deal with the problem in calculus by a function of single variable. But because now we have two variables, there's nothing much we can do now. However, I think the first equation can help us out. And let's see. I think we can use the first equation. The first equation means equals 100 plus y, right? And we can put it into the second equation. Let's see what's happening. And now it means the product is the same as 100 plus y, which is for the variable x times y, right? And we can expand it a little bit, so it is 100 times y plus y squared. And it's going to be a function of single variable of y now. It is a product function. And please recall, we try to minimize this quantity. It means that we try to search for the minimum value of the current function p of y. And it's a calculus problem now. Please recall how you can find the minimum. And obviously, it means the absolute minimum value of the product function. And maybe you can try to find a critical number first. And you can rely on either the first derivative test or the second derivative test to test the behavior of all these critical numbers. And we have to make the final analysis based on that. And let's look at it this way. Let's try to find the critical number first. The first derivative is 100 plus 2y. And to find the critical number, I set it be 0, and y is gonna be minus 100 divided by 2, which is minus 50. And it means we have only one critical number now. And let's test the behavior of this point by the first derivative test. And by first derivative test, now you have only one critical number and you have two intervals, the left hand side of -50 and the right hand side of -50, and you need to randomly choose one point in each interval. For example, for the left interval, I can choose something smaller than -50. Maybe I can choose -100. You can evaluate p prime at this point, and also you can choose a point that is bigger than -50. Let's say you choose 0, and you evaluate the p prime at this point. And it's actually quite easy to do the calculation based on the p prime, and we only care about the sign. For p prime of 0, it's going to be positive, and for p prime of -100 is negative. So I put the sign in, and this sign of the p prime means what? Minus means that the function p of y is going to be decreasing, so the tangent is going downward. And also, for the positive sign, the tangent is going upward. It means what? It means around this point. We expect that for the graph of p of y is a minimum, local minimum, basically. And let's think about this problem. Obviously, the function is very smooth and it is continuous, it is differentiable. And for such a curve that we have only one local minimum, essentially it means that it is the absolute minimum, right? Because for a curve like this, you have only one single point as the local minimum, which is for y equals -50, and there's no chance you can get below this point, because if you have some other points that is lower than this point, it means for this curve to have such possibility, maybe you have to have these scenarios, but which is impossible, because if you have this scenario, we should have another critical number which represent the local maximum, right? But we don't have such a second critical number. It gives you a sense that our local minimum is actually an absolute minimum, and that's the point that we are searching for. So it means that y equals -50 will give us the absolute minimum value. So let's compute this. P of y is actually the same as 100 times -50 times -50, the whole thing square, and it's gonna be -2500. And it is the minimum product that we can get for the pair of numbers we have. And what is x? Please recall that x by the first equation, x is equal to 100 plus y, which is -50 now. And it means x is actually the same as 50, right? So the pair of number we actually have is gonna be 50 comma -50, and it is a pair that can give us the minimum product. And the minimum product we have found it already, which is -2500. And that's the end of this problem.